Alright, in this video we're going to talk about 2.3 Day 1, solving trigonometric equations. So, solving trig equations is going to be very similar to algebraic equations, except instead of trying to isolate the variable, we're going to try to isolate the trig function. So, an example of that would be if we're given the equation 2 sine x equals 1, we're going to want to get the trig equation sine x by itself, so we're going to say sine of x equals 1/2. So, we're stuck now, sine of x equals 1/2. This is where our unit circle is going to come into play. So we're going to want to use our knowledge of the unit circle to find the solutions. So sine of x equals 1/2 is true when x equals pi over 6. So sine of pi over 6 is equal to 1/2 and 5 pi over 6. So sine of 5 pi over 6 is also going to be 1/2. But this is only true on our interval 0 to 2 pi. We're going to count the 0 and not the 2 pi. Right? There's going to be infinitely many more solutions here, right? Because we can go around the circle more than once. These two only tell us what happens if we go around the unit circle one time. So what we're going to have to do is come up with something called the general form. So the general form is going to take that x equals pi over 6, and it's going to say, well, not only pi over 6, but if I add 2 pi to it, I'm going to be in that same spot, right? So pi over 6 is like right here. We're going to go around the unit circle, 2 pi, end up at pi over 6. But we can also go around another time, and another time, and another time, or I can go backwards the other way. So we're going to say pi over 6 plus 2 pi times n, where n is going to be any integer, right? I can make n 0. 2 pi times 0 is pi over 6. We can make it 1. Pi over 6 plus 2 pi means we go around the circle once. It could be 2, go around twice. And then we're going to do the same thing for 5 pi over 6. So 5 pi over 6. And then every time I hit 5 pi over 6 as I go around the unit circle. Now we're picking plus 2 pi n because 2 pi is the period of sine. So if this were cosine, we would also do 2 pi n because that's the period of cosine. So we're going to look just at a few examples of some things that might show up and how we're going to tackle these things. So this one's going to be pretty basic. We got to solve for x. We got to get the sine by itself. So we can add this sign over and at the same time subtract our radical 2. So we're going to get negative 2. I'm sorry, not negative 2, positive 2. Right, add the sign over. Positive 2 sine of x equals negative radical 2. That's where the negative is coming from. Sine of x is not isolated yet, so we have to divide by 2. So sine of x is equal to negative radical 2 over 2. So now we got to think, unit circle, when does sine of x equal negative radical 2 over 2? Well, that's going to happen when x is equal to 5 pi over 4. And when x is equal to 7 pi over 4. The problem doesn't say just on the interval 0 to 2 pi, so we have to say not only 5 pi over 4, but every time after that when I go around the unit circle. Same thing with 7 pi over 4. So 5 pi over 4 plus 2 pi n, 7 pi over 4 plus 2 pi n. So let's look at another one. We can have something like this one where we have 3 tangent squared minus 1 equals 0. So we're going to get tangent by itself this time. So add 1. Divide by 3. So tangent squared of x is equal to 1/3. We don't know anything about tangent squared, so take a square root. Tangent of x is equal to the square root of 1/3, which is 1 over the square root of 3, which is radical 3 over 3. So we're going to have to try to find where tangent of x is equal to not just radical 3 over 3, but when we take a square root, we have plus or minus, right? So plus or minus radical 3 over 3. Now here's the problem with tangents. It's not just the x value, it's not just the y value. We have to think about dividing the y value by the x value. If there's radical 3's you need to pick either pi over 6 or pi over 3 and try it. So pi over 6 has the point radical 3 over 2, comma 1/2. So if we think about sine being the y value over the x value, or, tangent, or being sine over cosine, we're going to get 1/2 over radical 3 over 2, which is the same thing as 1/2 times 2 over radical 3. Your 2's cancel. 1 over radical 3, which is going to be radical 3 over 3. So we know pi over 6 is one of our answers. Pi over 3 is not. So we know pi over 6 is going to be our positive radical 3 over 3. So 5 pi over 6 is going to be our negative. So pi over 6 and 5 pi over 6. Now, here's going to be a little bit different from sine and cosine. This is not going to be plus 2n pi. This one's going to be just n pi, because the period of tangent of theta is equal to pi, not 2 pi. So we're going to say plus n pi here, not plus 2n pi. Alright, so let's switch gears a little bit and look at this one. Cotangent of x cosine squared of x equals 2 cotangent of x. So this is a little bit different than the ones we were just looking at before, because this has two different trig functions. We have a cotangent, we have a cosine squared. So we're going to want to move that 2 cotangent to the left-hand side to be with the other thing. So we're going to look at cotangent. We're going to look at cotangent of x cosine squared of x minus 2 cotangent of x equals 0. Now, ideally, we're going to want to pair the cotangents together and the cosine together. So since there's a cotangent in each piece, we can factor out a cotangent of x. And we can use our zero product property. Just like when we were factoring in Algebra 2, we would factor and set each piece equal to 0. We're going to do the same thing here. We're going to say cotangent of x equals 0. We're going to say cosine squared of x minus 2 equals 0. So we'll work this side first. Cosine x squared equals 2. Cosine of x equals plus or minus radical 2. Radical 2 is bigger than 1. So this is outside the possibility of cosine. There's no cosine that's going to give me radical 2, right? As big as I can get is 1, as small as I can get is negative 1. So this piece here, no solution. So now we got to look at this. Cotangent equals 0. So we got to think cotangent is cosine of x over sine of x. So that's got to be equal to 0. So cotangent of x is going to be 0 when x is equal to pi over 2. It's also going to be equal to when x is 3 pi over 2. But just like tangent, cotangent's period is pi. So if we put plus n pi here, that's going to take this one into account. Because if we add just 1 pi to pi over 2, we're going to get 3 pi over 2. So we don't really need this answer because it's going to be taken into account with our plus n pi here. Now, if you were to write it and give me a plus n pi with this one as well, it's not going to be wrong. It's just extra information that we don't actually need. So pi over 2 plus n pi. So 2 more quick examples, and then we'll call it quits on this video. So solve 2 sine squared x minus sine x minus 1, and that should say equals 0. Sorry. On the interval 0 to negative 2. I'm sorry, 0 to 2 pi. So now, because we have an interval, we don't have to put our plus 2n pi on here because it just wants the answers on our unit circle here. So we have a sine squared minus sine minus 1. We want to think about this as if it were just a normal quadratic equation. So if we looked at this and we saw 2x squared minus x minus 1 equals 0. we would think about factoring that. And that would factor into 2x plus 1 times x minus 1. So we're going to take the same idea here, but instead of x's, we have sines. So we're going to say 2 sine squared of x minus sine of x minus 1 equals 0. So instead of 2x plus 1, we're going to say 2 sine of x plus 1. And instead of x minus 1, we're going to say sine of x minus 1. And we're going to solve each of these individually. So 2 sine of x plus 1 equals 0. So sine of x has to equal negative 1/2. We're going to say sine of x minus 1 equals 0. So when does sine of x equal 1? So back to our unit circle, we have to think, all right, when do these things happen? Sine of x is equal to negative 1/2 when x is equal to 7 pi over 6. And when x is equal to 11 pi over 6. And then sine of x equals 1 at x equals pi over 2. And again, we're not going to need our plus 2n pi's here because we're on just the interval 0 to 2 pi. We don't care about all the extra answers. So last problem. And it's a bit of an issue here. So we have cosine of x plus 1 equals sine of x. It's not like that problem we had before where we could move the tangent to the other side and factor a tangent out because there's nothing to factor out. There's a sine, there's a cosine, nothing else. So what we have to do is get creative here a little bit. We need to make this in terms of just one or the other. So what we're allowed to do is if we take each side and square it, we're going to get cosine squared of x plus 2 cosine of x plus 1 equals sine squared of x. So now we've introduced squares. And that means we can use our Pythagorean identities. Now, we could, if we wanted, turn cosine squared into 1 minus sine squared, but that's not going to help with this cosine here. So what we want to do is turn this sine squared into 1 minus cosine squared, so we can have everything in terms of cosine. So cosine squared of x plus 2 cosine of x plus 1 equals 1 minus cosine squared of x. Move everything to one side. So 2 cosine squared of x plus 2 cosine of x, the ones are going to cancel, equals 0. And now we can just factor this, take the greatest common factor out. We can say 2 cosine of x times cosine of x plus 1 equals 0. So when is 2 cosine of x equal to 0? And when is cosine of x equal to negative 1? So 2 cosine of x is going to be 0 when cosine is 0. So that's going to be pi over 2 and 3 pi over 2. Cosine of x equals negative 1 when x equals pi. Now we do have a slight issue, and that comes in whenever we square something on each side. We're introducing the opportunity to get extraneous solutions. So what you're going to need to do anytime you square each side is check your answers, plug them into your original equation, make sure things work. In the interest of time, I'm going to tell you that pi over 2 works, 3 pi over 2 does not, and pi does. So again, anytime you square, make sure you check your answers. So that'll do it for this video, and then we'll see you in the next one.